Up in the night sky, we see stars, planets filling up the darkness, and a perfect masterpiece of art which just gets imprinted in our memory and a chilling vibe. And after that comes the questions, what is up there? And soon the night vanishes with the rays of something powerful to light up the entire solar system. So, whatever it is, our Earth and the other planets' characteristics depend on something which is very common to all of them, and all of them orbit it because they do not have the power to overcome the greatest gravitational force in the entire solar system by one thing, and that is our Sun. Let it be the biggest planet Jupiter, or the smallest planet Mercury, or the coldest Neptune, or the hottest Venus, or our Earth, where I and you live. At least that's what we know until an alien comes to your doorstep. All of these planets and their moons and other heavenly bodies orbit the Sun. The position of the other planets from the Sun itself gives the characteristics they have. Our planet Earth position from the Sun itself makes the planet habitable with life, as it is neither too cold nor too hot. So, why is this important to us? Sun is the source of energy and that which drives the life on Earth. Without it, we cannot imagine the photosynthesis process or any other life activity on Earth. The ecosystem and the entire nature depend on the energy which is supplied from the Sun. Entire diversity depends on this energy. If there was no Sun, our planet would become colder and colder day by day, freezing everything existing into cold ice. And its tremendous gravitational force, which keeps all the planets in an elliptical path around it, without which all the planets would drift off to an infinite journey in the deep space, and which would be too cold in about minus 270 degrees Celsius. That's too cold. So, what is this in the solar system? What are its properties? What is it made up of? How does it affect us? And many more questions to be answered. For all of that to be answered, let's know about it. Sun is one among the billion other stars in our Milky Way galaxy. It is a nearly perfect sphere and has a diameter of about 1.39 million kilometers. Oops, that's almost around 35 times the circumference of Earth. It means that you would have to circle the Earth 35 times. Its volume is 1.4 into 10 power 27 cubic meters. Let me give you an example. It means that we can fit 13 lakh Earths in the volume of the Sun, that is 1,030,000. That's huge. It was formed around 4.6 billion years ago, and according to the cosmic calendar, the Sun was born on August 31st. Because planets do not have their own nuclear fusion, they do not produce their own light. Instead, they shine with the light reflected from a star. So the next time you see a planet in the night sky, it is the light from the Sun reflected from the surface of that planet, and that reflected light reaching us. The connection and the interactions between the Sun and Earth drive the seasons, ocean currents, weather, climate, radiation belts, and the auroras. In our solar system, we have one star, but there are billions of stars like our Sun scattered across the Milky Way galaxy. Some of them have a system like ours, and other stars are single with no system around them. Coming back to our Sun, it plays a crucial role for life here on Earth, like the climate of an area concerns the average weather conditions. Different parts of the Earth have different climates because of different amounts of heat received from the Sun. Some climates have different seasons, and there may be little or much variation in precipitation and temperature. Weather changes so much because the Earth is constantly spinning. Lands and water bodies heat up differently, which causes constant atmospheric change. Also, note that seasons are not the same as weather. Seasons have to do with the angle of the solar radiation we receive caused by the tilt of the Earth on its axis. It's fact time. Our Sun is brighter than 85% of the stars in the Milky Way galaxy, and surely that makes the Sun the brightest object in the Earth's sky. Our Sun is situated in the Milky Way galaxy. It is a G-type main sequence star, also called a yellow dwarf or G-dwarf star, and it is a main sequence star of spectral type G. So what is a main sequence star? It is nothing but any star that fuses hydrogen in its core and has a stable balance of outward pressure from the core nuclear fusion and the gravitational forces pushing inward. Hence, it is a near perfect sphere. Sun comprises about 99.86% of the mass of the entire solar system. So the rest mass being 0.14% is just made up of the other planets, including the satellites and the asteroids, meteorites, dust, etc. Just imagine how big the sun can be to discover. But it is a gas giant, so I don't think you can land there to discover it. Space is all beyond imagination until it's discovered. Our sun is about 13 billion times brighter than the next brightest star Sirius, visible from the Earth's sky, which is about 8.6 light years away from our Earth. Light travels from the sun's horizon to Earth's horizon in about 8 minutes and 19 seconds, and it travels a distance of about 151.67 million kilometers. 151 million kilometers in just 8 minutes and 19 seconds can seem impossible, but at the speed of light it is possible. Its escape velocity is 615 km per second, where on Earth it is just 11.2 km per second, and surface gravity on Sun being 274 meter per second square. That's almost 28 times greater than that of Earth. I guess we could barely walk up there, or who knows, we might even get crushed. Its mass being 1989, 100, 000, 000, 000, 000, 000, 000 kg. That's okay, just ignore that. The Sun has a family of 8 known planets, which includes 4 terrestrial planets. They are Mercury, Venus, Earth and Mars, 2 gas giants, Jupiter and Saturn, and 2 ice giants, Uranus and Neptune. That's not it, we have at least 5 dwarf planets, an asteroid belt, numerous comets, and a large number of icy bodies which lie beyond the orbit of Neptune. Our solar system is moving with an average velocity of 450,000 miles per hour, that is 720,000 kilometers per hour. But even at that speed, it takes about 230 million years to make one complete orbit around the Milky Way. Like all the other stars in the universe, our Sun is a gas ball and is made up of 91% of hydrogen and 8.9% of helium. The Sun's original chemical composition was inherited from the interstellar medium out of which it formed. At this time in the Sun's life, they account for 74.9% and 23.8% of the mass of the Sun in the photosphere respectively. The heavier elements called metals in astronomy account for less than 2% of the mass, with oxygen roughly 1% of the Sun's mass, carbon 0.3, neon 0.2 and iron 0.2 being the most abundant. Since the Sun formed, the main fusion process has involved fusing hydrogen into helium. The Sun shines because it is able to convert energy from gravity into light. This is what happens to the hydrogen gas in the core of the Sun. It gets squeezed together so tightly that 4 hydrogen nuclei combine to form one helium atom. It's fact time. Did you know Sun rotates faster at its equator than at its poles? This differential rotation is caused by convective motion due to heat transport and the Coriolis force due to the Sun's rotation. The Sun currently fuses around 600 million tons of hydrogen into helium every second. It is converting 4 million tons of matter into energy every second as a result. And the Sun spins once every 25 days, but at its poles, it rotates once every 35 days. The Sun is a star and the only one we can see during the daytime. When we look in the night sky, we see endless dots of light. Every one of them is a star just like our Sun, far away from us. That's the end of the first part of this video. Stay tuned for the next part as we get inside the Sun and know about it. If you like the video, please like, share and subscribe, and stay tuned for another Lighted Sky video. Thank you.